Look out at the night sky. If you're lucky enough to be away from the glare of city lights, you'll see thousands of stars. Each one is a sun, a distant furnace warming its own family of planets. Our galaxy, the Milky Way, contains up to 400 billion of these stars, and our galaxy is just one of an estimated 2 trillion galaxies in the observable universe. The numbers are so vast, so mind-numbing, they defy human comprehension. Out of this near-infinite cosmic ocean of worlds, with billions of planets orbiting in the life-friendly habitable zones of their stars, and with billions of years for life to emerge, the question isn't if alien life exists. The real question is, where is everybody? This isn't just some thought experiment. This is a profound and unsettling mystery known as the Fermi Paradox, first posed by physicist Enrico Fermi during a casual lunch back in 1950. For decades, that question has echoed through the halls of science, a nagging reminder of the eerie silence that greets our telescopes. We've been listening, we've been searching, but the cosmos remains quiet. We've come up with dozens of theories to explain the silence, from the hopeful to the truly strange. But among them, one dark possibility has started to gain traction, a potential solution that is as elegant as it is terrifying. What if the silence isn't an accident? What if the reason we're alone is that we're living inside a cosmic graveyard, and we just haven't realized it yet? This idea suggests there's a cosmic filter that we are fast approaching, and that no one has ever passed. The great silence and its ominous riddle. To truly feel the weight of this problem, you have to understand the scale. Let's try to bring it down to earth. Imagine the Milky Way galaxy is the size of North America. The number of stars in our galaxy alone is comparable to the number of grains of sand you'd find on that entire continent. Now, here's the kicker. We know that planets aren't the exception. They're the rule. It seems nearly every star has them. Based on data from missions like Kepler, scientists estimate there could be tens of billions of Earth-like planets in our galaxy alone, planets with the right size, composition, and distance from their star to host liquid water, the key ingredient for life as we know it. The universe has been around for nearly 14 billion years. Our solar system is a relative newcomer, at about 4.5 billion years old. That means there have been billions of years for other civilizations to arise, on other worlds, around other stars. Even if a tiny fraction of those worlds developed life, and a tiny fraction of that life became intelligent, and a tiny fraction of that intelligence built a technological civilization, the galaxy should be teeming with activity. Think about our own technological growth. In just a few thousand years, we've gone from farming to splitting the atom and walking on the moon. A civilization just 1 million years older than Esau, blink of an eye, in cosmic time would be so advanced they seemed like gods. Their technology would be like magic to us. They could have colonized huge parts of the galaxy, built Dyson spheres to harness their star's entire energy output, or left behind unmistakable technosignatures we couldn't possibly miss. A civilization with self-replicating probes, traveling at just a fraction of the speed of light, could map the entire Milky Way in about 10 million years. Given the age of the galaxy, it should have been visited and colonized hundreds, if not thousands, of times over. Yet, we see nothing, we hear nothing. The radio telescopes of SETI, the search for extraterrestrial intelligence, have scanned the skies for decades, and while the search is far from over, so far they've found a profound, deafening silence. This is the Fermi Paradox in its stark, terrifying clarity. The numbers say the universe should be a bustling cosmic metropolis, but what we actually see is a silent, empty void. It's a contradiction so profound it demands an explanation, and every potential answer has staggering implications for our future. Introducing the Great Filter, one of the leading explanations for this cosmic silence, is a chilling concept known as the Great Filter. First proposed by economist Robin Hanson, the theory isn't a physical wall, but a conceptual barrier. It suggests that on the long, difficult journey from simple, non-living matter to a galaxy-spanning there is at least one step that is almost impossibly hard to overcome. This filter is a hurdle so high that almost no life ever clears it. Think of it like a long staircase. You start at the bottom with the right kind of star system and a planet that can support life. The next step is for life to actually emerge, a process called abiogenesis. Then, that life has to evolve into complex, multicellular organisms. From there, you need intelligence, then tool use, and eventually a technological society. The final steps would involve surviving long enough to colonize other worlds and spread across the galaxy. The Great Filter theory says that somewhere on this staircase, there's a step so improbable that it stops almost every civilization that ever gets started. The universe isn't silent because life is rare. It might be silent because something prevents life from becoming loud. The great silence might not be an absence of life, but the sound of universal failure. This raises the most important question humanity could ever ask. Where on this staircase is the filter? Is it in our distant past, or is it lurking in our future? Because if the filter is behind us, the universe could be ours for the taking. But if it lies ahead, we might be on the verge of our own extinction. For a long time, we clung to the hope that the filter was behind us. We looked at our own improbable history and thought, maybe we're the miracle. Perhaps the great filter is the jump from primordial soup to a self-replicating molecule, or maybe it's the leap from a single-celled organism to complex, multicellular life. If this were true, it would mean we're one of the first intelligent species to make it this far. The vast, silent cosmos would be an empty frontier, waiting for us. But what if we're wrong? What if the silence isn't a sign of our unique success, but a warning of impending doom? What if the most likely solution to the paradox is that the great filter is still ahead of us? Deconstructing the hopeful but wrong answer, let's look at the optimistic scenario for a moment, the one we all want to be true. The idea that the great filter is in our past is incredibly comforting. It paints humanity as special, a rare gem in an otherwise barren cosmos. This hypothesis argues that one of the early evolutionary steps is the one that filters out almost everyone. Maybe the filter is abiogenesis itself, the creation of life from none. We still can't replicate it in a lab, so it could be a 1 in trillion fluke that happened here, and almost nowhere else. Or maybe it was the emergence of complex cells, the building blocks of all animals and plants. That leap seems to have happened only once in Earth's history and was a monumental step. Another candidate is the evolution of big-brained, tool-using intelligence like ours. After all, life existed on Earth for over 3 billion years before one species started looking at the stars. This line of thinking is seductive, but there's a potential flaw in this hopeful logic. As our understanding of biology and planetary science deepens, these insurmountable hurdles start to look a bit smaller. Astrobiologists now think the basic building blocks of life are common throughout the universe. The transition to multicellularity, once thought unique, has actually evolved independently multiple times right here on Earth in different lineages. And evolution often finds similar solutions to similar problems, which suggests that intelligence and tool use might not be such a fluke after all. The more we learn, the more it seems the early steps for life might not be the hardest ones. The universe seems primed for life to emerge and even become complex. And if that's true, the galaxy should be filled with intelligent species. If it is, but we hear nothing, that forces us toward a much darker conclusion. Maybe the filter isn't behind us. Maybe the silence is the sound of other civilizations reaching our stage of development ... and then vanishing. The filter is ahead. This is the terrifying potential solution to the Fermi Paradox. The idea that the universe is silent because there is a barrier that lies between a civilization at our level of technology and one that can travel between the stars. A barrier that, so far, no one has survived. This future filter could take several forms, but they all point to the same grim outcome: self-destruction. The most obvious candidate is that civilizations inevitably develop technology that is too powerful for their own wisdom to handle. We see the seeds of this in our own world. We created nuclear weapons and have spent decades in a precarious balance that could end it all. Now, consider the potential for genetically engineered pandemics or runaway artificial intelligence. Many top AI researchers worry that an ASI, an artificial superintelligence, could pose an existential risk, developing goals that don't align with ours and seeing humanity as an obstacle. A second, more subtle possibility is what you might call the sustainability filter. This theory suggests that any civilization that pursues rapid, exponential growth will inevitably exhaust its resources and collapse. We see the warning signs on our own planet with climate change and resource depletion. Maybe the only way to survive long-term is to adopt a model of slow, sustainable living. But such a civilization might never develop the massive energy required for interstellar travel, becoming invisible on their quiet home world. Finally, there's perhaps the most frightening idea of all: the dark forest hypothesis. Popularized by a science fiction novel, this theory suggests the universe is like a dark forest at night, filled with armed hunters. You can never know the intentions of another species, so the only safe, logical move is to eliminate any other life you find before it eliminates you. In this scenario, broadcasting your existence is a death sentence. The silence isn't because no one is out there, but because the ones who are still alive know to stay quiet. Our messages sent out into space could be the naive cries of a child, alerting every predator in the forest to our location, whether it's self-destruction, unsustainable growth, or cosmic predation. These potential future filters all paint a bleak picture. They suggest that the universe is silent because it is a graveyard of civilizations that reached our stage of development ... and failed their final test. Exploring these ideas isn't just a cosmic curiosity. It's critical for our own survival. It forces us to confront the profound risks we face as a species. The questions raised by the Fermi Paradox are some of the most important we can ask. If you want to continue exploring these cosmic mysteries and what they mean for the future of humanity, consider subscribing and joining the conversation. We need more people thinking about these challenges. What if the eerie silence of the cosmos isn't an invitation, but a warning? For decades, we've looked at the stars with a sense of wonder, hoping for connection. But we may have been misinterpreting the message. If this solution to the Fermi Paradox is correct, the universe isn't a cradle for life, but a crucible. And our final test is yet to come. If the great filter is indeed ahead of us, then we are living in the most dangerous period in human history. We're standing on a precipice, armed with godlike technologies but wrestling with flawed, tribal instincts. We are rapidly approaching a bottleneck that may have extinguished every civilization before us. The challenges of climate change, nuclear proliferation, and artificial intelligence aren't separate problems. They are the potential components of the great filter. They are the final exam we have to pass together. The silence of space is the evidence. It is the theoretical result of countless other civilizations who also looked up at their stars and dreamed of the future. Civilizations that, for whatever reason, never made it. This realization is profoundly sobering, but it doesn't have to be a death sentence. It can be a call to action. Knowing that the filter is likely ahead gives us a terrifying, but unique, advantage. We can see the test coming. We can identify the risks and work to mitigate them. It tells us that our greatest challenge isn't conquering space, but conquering ourselves. What if we're not alone, because life is rare, but because we are simply the next in line? The silence may be the final transmission from all who came before. A message that says, we didn't make it. The question is, will we?